Hi, I'm Starr Howe. I'm an environmental literacy coordinator in San Diego at the San Diego County Office of Education in California. And today I'm going to talk to you about environmental phenomena in early mathematics. So, almost universally, adults have a happy memory of spending time outdoors. This time might have been spent at the beach, making a mud pie, riding a bicycle, or playing with friends. Think for a moment about a time that you enjoyed being outside as a kid. Research is beginning to show us that time spent outdoors has positive benefits on well-being and pro-social behavior. Why then, when we know that going outside is so beneficial to humans, do we keep students indoors for most of their learning experiences? Sometimes this is because we don't connect time spent outside to the productivity needed to engage in education and careers. So let's take a moment and consider how going outdoors might be applied in adult life. Take a moment and think to yourself, what careers ask their professionals to go outside? Did you picture cartographers, urban planners, or landscape architects? What about environmental surveyors, park rangers, or hydrologists? You might have considered astronomers, farmers, adventure guides, or biologists. We often forget how many interesting and high-paying careers require professionals to enjoy being outdoors. To help students see themselves in these positions, they need to learn outside the classroom and see how the skills we use inside our four walls are applied in the real world. To prepare students for these types of STEM careers, they need practical experiences, critical thinking, collaboration skills, and a comfort with learning both inside and outside. Bringing mathematics outdoors using environmental phenomena in the early grades can help students build a foundation that will stay with them throughout their educational experience and into their careers. So let's clarify what environmental phenomena are. They don't have to be explosive or phenomenal. The purpose of phenomena is to allow students to attach their learning to something concrete and observable. This makes learning more relevant to students. And by recognizing that mathematics is everywhere in the world, students can develop more positive attitudes towards mathematics, which supports their continued engagement in math through their education and into a career. The definition we use of environmental phenomena is anything that students can observe in the world around them, which causes them to wonder and ask questions. That's a pretty broad range of topics when you think about taking kids outside. We can find these phenomena in the garden, the schoolyard, or even the local community. All of the living and non-living areas of the schoolyard can be sources of environmental phenomena for young students to engage in mathematics. Take a moment and think about a schoolyard you have spent time in recently. What shapes did you notice? How many different environments could students explore? What objects in the schoolyard move or change during the school year? Did you think about the shapes you can see in the playground structure? What about shaded and unshaded areas of the playground? I worked with a kindergarten teacher whose children visited the same tree every week during the school year and noticed how much it changed week over week, season after season. You might think about a garden area or a grass field or a dirt hill on the side of a blacktop. Students in K through 2 can explore the temperature of different areas with or without thermometers. They can count the number of weeds coming up through a sidewalk, and they can investigate how long it takes a snail to move across the grass. The San Diego County Office of Education has been supporting curation of environmental phenomena resources that can help teachers to identify local phenomena for students to engage in. These resources are written for specific grade levels and are a great source of inspiration and ideas for using the schoolyard. You can see two examples here. Our first grade example is that plants don't eat or grow like I do. And the second grade example ties back into that thinking about measuring temperature with or without thermometers. A rock in the sun is warmer than a rock in the shade. So now that we have an shared understanding of an environmental phenomenon, let's delve into the mathematics side of things and see how that plays into getting students prepared for STEM careers. We know that TK2 instruction is the foundation to preparing students for these sorts of careers. We want students to feel efficacious in STEM, and that means that they need hands-on, minds-on learning and opportunities to be curious and engage in their own investigations. Providing students with relevant experiences that mimic what actual professionals do, even in the earliest grades, supports students' positive attitudes towards STEM and helps them see themselves as mathematicians. We often focus on formal learning in classrooms, where we think about students at their desks or at the rug. But learning can happen at home, at school, during a field trip, or on a walk in the neighborhood. When children engage in self-directed play, their experiences can result in learning. What if we could leverage this aspect of play and curiosity to encourage students to engage more deeply in their own learning? During COVID, we had the opportunity to see students learn at home. For example, these children on a hike, making their own lunch, or helping dig for the garden in the backyard. These students were able to use something they were naturally interested in and were bringing science and mathematics to the work that they did without thinking about it. If we could leverage that natural curiosity to support student learning in school, then we could be stimulating their curiosity and keeping their enjoyment and engagement of mathematics going. Sometimes the four walls of our classrooms are not always the best locations for these types of engaging experiences, and that's why it's helpful to take them outside. Students can engage in environmental phenomenon more than one time at school. They can formally bring their mathematics skills and thinking from across content areas to explore or describe a phenomena in kindergarten, such as the one we saw with the sun making some areas of the playground cool and some warm. And then they might come back to those same ideas in grade 3 with more complexity and a richer phenomenon. Maybe they're describing the climate of the school building. They might even informally consider the environmental phenomena they see at school with a different lens between formal learning experiences, just because they're going to run into it more often when they're at recess or lunch. As we consider how students interact outside the classroom, it pushes us to see how we can replicate that less structured learning. One indicator is to consider how many decisions students are making. When students are in the driver's seat, they make more decisions than when they are mimicking their teacher. Think for a moment about the implications that this can have for students' mathematical learning. We also know that students have improved self-image, stronger relationship building, and are less anxious when they spend more time outdoors. Bringing mathematics, a subject that students are often negative or concerned about, outdoors can positively affect their relationship with their own mathematical learning. So what does this look like in practice? It often feels like a heavy lift to move instruction outside, but it doesn't have to be. We are going to run through an example lesson together to help bring the idea of mathematics in an outdoor space into clarity. While we talk through the lesson, I'm going to pause so that you can think about the activities for yourself. You may notice spaces where this learning experience provides an opportunity to bridge between learning indoors and outdoors for students. We're going to look at a garden phenomenon. This learning series engages students in thinking about the three sisters. This is an indigenous story used to describe a section of companion planting where beans or peas are grown alongside corn and squash. And this has been used in the United States, across the US since indigenous times, and is still in use today. As you take a look at this image of the three sisters, what does it tell you about what corn might need to grow, what peas might need to grow, and what squash might need to grow? Beginning with the peas, we could have students journal as a way to engage them in noticing the plants that they are working with. Nature journaling is a way for students to share their thinking and their questions about phenomena through words, pictures, and numbers. Students might journal about one environmental phenomena many times during a school year, or they might sharpen their observational skills while journaling about a variety of spaces within 1 week. My daughter had the opportunity in second grade to nature journal every Friday afternoon at the same plant that she picked out the very first week of that school year. And she was always thrilled to tell me how much it had grown, how wide it was, how many leaves she counted, really bringing that informal mathematics in every time she went outside to nature journal. We can ask students to journal about these similarities and differences between the germinated pea plant, shown on the left, and the growing pea plant, shown on the right. This could be shown in the classroom through pictures, or students could go out in the garden and actually look at what's growing or look at a germinated plant. They could even be brought in little containers for students to look at. This allows students to engage in learning and thinking about these plants with multiple modalities and at their own level of comfort. When we think about our students in early education, they're not always ready to write. They might prefer to draw or use numbers or tick boxes. And this really allows them to bring their thinking and their noticing in ways that are comfortable. Once students have had some thinking about our pea plants, we're going to move to thinking about how they might organize and plant their garden. This grid represents the type of device that we often see our gardeners use, which gets pushed down onto a plot of a garden bed. And that tells us how to separate out our seeds so that our plants have enough distance to grow without having to measure in between each one. So our students might look at this grid and plan how are they going to plant the corn, peas, and squash in their garden bed. First, we might ask students to tell us how many squares are even available to plant with. This is an excellent opportunity for students to share how they'd solve this problem in a variety of ways. Consider to yourself, how many ways can you identify the number of squares in the garden bed? Once we have an understanding of the entire garden plot, students would need to identify where they would put their corn. We would let students know that the corn needs to be grown close together. It gets very tall, but we don't want it to block the other plants from getting sunlight. Students might need to observe the garden multiple times to gather information about the sunlight and how it moves during the day, maybe to think about shadows from tall objects or small objects. Once students decide where in their plot that they're going to put the corn, they can describe how much of the garden is corn. Again, this gives them an opportunity to share their own methods to their group or class. Where would you put the corn in this garden bed? Next, students can decide where they would put their squash. They need to know that squash needs a lot of space to grow across a garden bed and that the squash plants should be as far from one another as possible. Again, students can share how they arrived at describing how much of the garden is squash. Where would you put squash in this garden bed? Finally, students need to decide where they would put their peas. They can use the information that peas need a lot of plants. They need to grow tall, clinging to something else. Students can describe how much of the garden bed is peas, and how does that compare to how much of the garden bed was corn or squash? Where would you put peas in the garden bed? Notice that along the way, students should be assessing how much of their garden is each plant. They could also describe their garden using spatial relationships, such as in front of, behind, or next to. After planning, students should plant their garden beds. You might have the class choose 2 or 3 options from students' ideas for how the bed should be organized. It's okay if they aren't all the same, and it's okay if they all don't grow perfectly. That is part of the learning, and students should be asked to share their ideas about why one bed might grow differently than another. How did one bed get more sunlight or less sunlight? Students can also look for patterns in how the plants were put into the beds. They could compare how much space each bed has for peas. Did they all end up the same? Students can observe the plants as they grow to look for a variety of heights, lengths. They could count number of plants, number of peas, number of ears of corn, as they check in about how the beds are doing along the way. We could even extend this into more mathematics by having students investigate the soil. Students could look at different types of soil or soil from each garden box that's available. They could begin by describing the soil in their journals, weighing the soil, standard or non-standard measurements for that. They could describe the size of the soil, the shape of the soil. As a class, they could come up with a way to delineate if they think the soil is made of big pieces or small pieces and what that means to them. Then students could plan an investigation to identify how much water moves through the types of soil. Teachers could give coffee filters and cups or beakers to students, along with water and cups of soil, and let the students make their own plan. Allow them to try that plan on, see how it works, and make a new plan. Allow them to share plans across groups. This gives students a chance to measure in a variety of ways and to use their descriptive language to share with one another what they observe about how water moves. This can be a highly structured activity or shared with very few parameters for students to allow them to use their natural curiosity to decide how to investigate the water and soil interactions. Even better, by moving this investigation outdoors, students have space to work and can be messy, which is sometimes very hard for us to do in the classroom. As students collaborate in groups, they can look for patterns, use clarifying language, and negotiate ideas to plan and enact their investigations. All of this supports their ability to collaborate and work together in the future. We could then have students develop a table that allows them to investigate their gardens over time. Students could identify how they want to measure their plant's height, how they want to describe their plant, and then use this to investigate changes in the garden over time. This is an example of a data table students might use to track their gardens and its growth. They could do just a pea or corn or a variety of plants. Students could visit the beds once a week. They could go as a class. It could be a rotation where someone's assigned a classroom responsibility to visit the garden. How might this expand students' use of mathematics on a regular basis during the investigation? All right, thank you for engaging in that example with me. Hopefully, one of the things that you noticed is that students are really at the center of this learning. They have the opportunity to make a lot of decisions, to drive the learning in a variety of ways, while it's organized and set up by the teacher to allow them to really engage in math in a way that feels relevant and authentic. As you think about the experience we just looked at, these are some of the mathematical ideas that students are engaged in during this experience. While planning the garden, students were describing the space, they were counting, they were thinking about how much was a pea or corn or squash. While investigating the soil, students are measuring, they are using describing words, they're trying to identify together a relative way to understand maybe big or small particles of sand or soil. And while planting the garden, they are measuring, they're using a data table, and they're again describing maybe the shapes of plants or counting the leaves that they see. What other opportunities for mathematics do you think you could bring into this lesson? We use instructional routines in the classroom as a way to regularly engage students in learning. These repeatable and often content-specific routines allow our students to apply their mathematical thinking to novel situations. These are some of the early mathematics routines that we think about using in the classroom for TK2. There's value in how these routines help students to build a strong base in mathematical thinking. What's even better is that students see them in learning, and regardless of the instructional materials we use, we can adapt these routines to come into the classroom and outdoors. Students count, especially collections. They might sort, deciding if something's, say, red or blue. We have students group objects together based on what's the same or different about them. My favorite is having students notice and wonder. We use that across content areas to really get an idea of what students are observing, how they're using all of their senses to observe, and what they're thinking about, what they might want to investigate later. This idea of order and space allows us to think about how students compare objects. Patterns might be red, blue, or it might be what we saw in the garden bed. Did all of the corn end up in the same place across everyone's plans? We have students share with us what's the same about objects and different. And again, they might use that for sorting or grouping, just the same way we might have them do that with comparing and contrasting as they get older. So some examples of how these might look with environmental phenomenon. Students might collect objects on the schoolyard, such as pine cones and rocks, and then they could decide within this collection how they want to sort it out. They might see if other classmates sort in the same manner. This particular student sorted pine cones from rocks, but she might have sorted based on size and had smaller pine cones that were the same size as rocks end up in one of her groups. This leads to rich opportunity for discussions about what students notice about the objects and how they think about organizing objects based on their shape, size, and measurements. Students might count collections, or they could count petals of a flower, ridges on leaves, worms in the grass, the number of peas growing in their garden box. The opportunities for students to count in the schoolyard are endless. Students can also use standard and non-standard measurement outdoors. This student is using her hand to figure out how long an ear of corn is. Students could bring in tools that they use in the classroom for non-standard measurements, such as paper clips, and apply those in the outdoor setting. Students also might use the idea of same and different to describe natural objects, such as these 2 ears of corn shown on the right. They could count how many kernels are missing. They could use non-standard measurement to identify which one is taller. They might even use some sort of system to weigh them and decide which one has more mass. Building mathematical noticing and the ability to describe objects to one another is an important foundation to mathematics for students. And again, the schoolyard has a huge variety of spaces that students can do this with. Ultimately, to bring mathematics outdoors, teachers have two main jobs. One is to set up and maintain the learning experience for students. This can happen by providing tools for exploration and mathematics, encouraging students to be curious or investigate differently than other students, and asking questions as students work to extend their thinking in new ways. The second role of the teacher is to identify the experiences that students might engage in. This can happen by walking through the schoolyard as a grade level team and looking for what stands out to you, what calls on your own curiosity, or by considering what mathematics activities you do indoors that could be enhanced by taking them outside. I often hear that while teachers are interested in the idea of moving their mathematics instruction outdoors, the practical issues of which space in the schoolyard to use or how to keep the students from running off to the monkey bars feels overwhelming. Ultimately, the more often students learn outdoors, the more easily they transition from indoor to outdoor learning spaces. Setting up blankets to sit on or a shade area can help students think of the outdoor space as a learning area. Using a timer to allow students to investigate and a return signal the same way you do for the rug in the classroom brings students back to their meeting spot to have a discussion. While beginning to utilize outdoor spaces, it is often helpful to have a buddy teacher or a parent volunteer to provide an extra set of eyes. If teachers want specific support for routines they can use to walk students from the classroom to a specific location in the schoolyard, or for support in leading class discussions outside, our informal educators, such as zoo, park, and garden educators, have an amazing skill set. Reaching out to a local community-based program or visiting the Beatles Project from the Lawrence Hall of Science can give you tools and ideas on how to make managing an outdoor learning space successful. To prepare students for STEM careers, they need practical experiences, critical thinking, collaboration skills, and this comfort with learning both inside and outside. By bringing mathematics outdoors, using environmental phenomena in the early grades, you're really helping students build that strong foundation that stays with them throughout their K-12 space, into college and careers. Thank you for your time today. The web locations of those environmental literacy resources and the Beatles Project are showing here in case you want to visit those at a later date. Thank you. Hi there. Thanks for joining us today, and I would love to have any questions dropped in the chat that you're interested in asking. So Lisa, our environmental phenomena resources from the San Diego County Office of Ed. Oh, there we go. There's those environmental literacy resources. So you can see them right there from the NGSS Resource Center at SDCOE. Thanks, Eric. And all of those, each of those is an individual link to a resource. So there's 102 of those and constantly growing. Lots of them in K1-2 space, which is really exciting. So feel free to look at that. And there's that Beatles project. So you'll just Google Beatles, like it is there with 2 E's. Project Lawrence Hall of Science, and it should pop up. Thank you. Oh, sure, Call. That's a great question. Thinking about health-related questions in the soil. And so when we think about what students are touching, we try really hard. I mean, there's a lot of rules around gardening in schools where we don't actually bring any compost in that includes waste. And so as long as the soils are clean soils, if they're made of dirt, if they're made of vegetation, if they're decomposing our own clean compost that we make within schools, then they're totally fine for students to handle. And we teach kids really fast to wash their hands after they do gardening work. So maybe that includes Having a sink that's available that they can get to outside. It also can include having a clean bucket that they learn how to do some hand dipping in the clean bucket and then wiping their hands afterwards, so that they don't put soil in their mouth. But they tend to be really good about it. And as long as you know that your soil's clean and doesn't have animal waste in it, then it's usually good to go. It's a great question. We'll do a final ask if there's any other questions. And if there's not, then we'll give you a couple minute break here before you transition over to your next session. All right. Thank you for joining us today. And I hope you get kids outside.